In this video, I am going to be looking at Neco Physics Practical 2022 Mechanics on cantilever. A cantilever is just a beam. So this beam, in this experiment, our beam is the meter rule, this meter rule with a hanger here. Then I have another meter rule fixed to a retort stand. In this experiment, the 50-gram mass hanger is fixed permanently at this point, which is 10 cm from this end. This is a G clamp which is used to hold this firmly on a table. Now, without much ado, let's just quickly run through the instructions so that we can carry out the experiment. Hold the meter rule firmly with a G clamp on the table. Attach a pointer at the tip of the meter rule. Also attach another meter rule on a retort stand, which I've already shown to us. This is the pointer here, and this is the mass hanger. Set the pointer and record the value for X0. So we are going to record the value for S0. Take note of that. Then attach a mass hanger of 50 gram at the point, 10 cm of meter rule from the end of the meter rule. Okay, we have recorded that. Maintain the position of the mass throughout the experiment. That is, we are going to keep that permanently at the 10 cm mark. At the 10 cm mark, place the mass hanger inside water in the beaker and record SW. So we are going to record X for the 10 cm mass, for the depression on the meter rule when we put it in air. Then after that, we are going to put it in water and we record the depression as SW. So when we record that as SW, we record that again. Then we are going to repeat the procedure for 4 other values where we have 10 gram, 150 gram, 20 gram, 250 gram. In each case, record X and SW. So we have to record S in each case and SW. Then we have to evaluate S equals X minus SW and S raised to power 3 minus 3 rather. Tabulate your reading. Plot a graph of this on this. In this experiment, I will not be plotting the graph. I will just show you how to get the reading. Now I have already drawn my composite table for this. So my table is going to look like this. So I have S0. I have X, which is the depression in gram. Okay, I omitted something from my table, so I'm going to include that now on the table. The masses, I'm supposed to include the masses. I'll just remove this, the serial number, and change that to the masses. So I have included the masses there. So this is 50 gram for the mass hanger. Then I will attach another 50 gram to the mass hanger, making it 100 gram. I will attach another one, making it 150, and so on and so forth until I get 200, until I get to 250. Now I'm going to perform the experiment to get the depression on air first. Then later I will go back and perform the experiment to get the depression for water. Then I will evaluate all of this. So let us quickly run through the setup. Now this is my setup. As you can see from here, you can see the meter rule and my slotted masses with the mass hanger. The meter rule is fixed to the table with the mass hanger. Now the length of this is a little bit long because the meter rule is not that firm. When we start to put the masses, it may have a depression. So we have the retort stand. This is the retort stand and the other ones. So I have the retort stand and the other meter rule. Now this is the pointer on the meter rule. So you can see the pointer on the meter rule. So that is what we are going to use to determine our reading. So that's the setup. So let us quickly carry out the experiment. So the first thing I'm going to do is to place the mass hanger. I'll place the mass hanger on the string on the 10 cm attached to this. So I'll place, now first of all I'll record my S0. my S naught is, from here, is 13. So I'll record that as 13.0. Then when I place this, I'll now get the depression. So this is my depression, that is 17.2. So 17.2 minus 13. That gives me 4.2. So I'll record that as 4.2. Next, I'll add another mass to this. So when I add another mass, this gives me 100 grams. So let me take the depression. So I have 22.2 minus 13. So you know when we did not add the mass, the length was at 13. So the depression is 22.2 minus 13, and that is going to give us 9.2. So I'll record that. So I'm going to add another mass. So my new depression is going to be 28. So I have 28 minus, which is equal to 15. So next I'm going to add the next mass. So this makes it 200 grams. So I'll take the depression. So the depression is at 32.5. So I have 32.5 minus 13. So I have 19.5. And finally, I'll add the last mass. So my depression is going to be, let us allow this to balance. (36.2). So I have 36.2 minus 13. So that gives me 23.2. Next, I'll place this inside the beaker and check for the depression. So let me check the depression. So I have 16.9. So I have 16.9 minus 13. That gives me 3.9. Next, I add another mass. So on adding another mass, I'll check my depression as 21.7. So I have 21.7 minus 13. That leaves me 8.7. Next, I add another mass to make it 150. So I'll check for the new depression. So I have 26. So I have 26 minus 13. That leaves me with 13.0. Okay, from this, you can see that I'm having a little bit of problem. This is about to touch this. So I have to change this, my stand, and place another one there. Okay, we're all set again. So now I'll add another mass, making 200. So I'll check for my depression. So my depression is going to be 35.7. So I have 35.7 minus 13. So that leaves me with Okay, let me take that readings again. That leaves me with 12.7. And finally, I'm going to add the last mass, making 250. So I'm sure that it's not touching this, it isn't touching it. So my depression is 34.2. So I have 34.2 minus 13. That gives me 21.2. So these are my various readings for the depression in air and also in water. So I'm going to evaluate all of this. If it's possible, I may plot the graph, but you can try it, the graph on your own. You can try the experiment on your own and also plot the graph on your own. So these are my evaluated values, and you should also know that x raised to power minus 3 is the same as 1 over s raised to power 3. So that is how I have evaluated this column over here. So you can plot the graph, and you can try this on your own and also plot the graph on your own.